We spend a lot of time looking up, worrying about threats from space, like asteroids. But what if one of the biggest dangers to our planet isn't out there, but is actually right here, sleeping just under our feet?
Take Yellowstone National Park. For years, we thought we had a pretty good idea of what was going on with the supervolcano underneath it. Turns out, we were only seeing a tiny piece of the puzzle. The reality is so much bigger.
I want you to look at this number, 46,000 cubic kilometers. Right now, it's just a number, but I want you to burn it into your brain because it's the key to a discovery that completely changes our understanding of the forces at work deep inside our own planet. So what is that number? Well, that's the volume of a second, previously unknown magma reservoir that scientists just found deep beneath Yellowstone, a colossal chamber of molten rock we had no idea existed, and it's 4.5 times larger than the already massive one we've been watching for decades. So, what does it actually mean to find a second, even bigger magma chamber? To really grasp the scale of what this is, we first have to understand the terrifying machine it's a part of, a supervolcano. Yet finding this thing isn't just about a bigger volcano. This discovery helps us understand the engine behind a geological force that has planet-altering potential. So before we circle back to this new reservoir, we need to talk about the kind of power it could one day fuel, a super-eruption. The name super-eruption gets thrown around a lot, but what actually makes an eruption super? Well, it all comes down to a scale designed to measure volcanic power. Officially, a super-eruption is any eruption that hits an 8 on the Volcanic Explosivity Index, or VEI. And what that means is it blasts out more than 450 cubic kilometers of magma. Now, to put that into perspective for you, that is enough material to bury the entire state of Texas ankle-deep in ash. A lot of us remember the eruption of Mount St. Helens back in 1980. It was a huge, historic event that literally blew the top off a mountain. On the VEI scale, it was a 5, a really powerful event for sure. But as you're about to see, compared to what we're talking about, it was just a firecracker. Now, the thing you have to understand about this scale is that it's logarithmic. Each step up isn't just a little bit bigger, it's a 10-fold increase in explosive power. So check this out. If Mount St. Helens was a firecracker, then Krakatoa was like a stick of dynamite. Tambora, that could level a whole building. But a VEI-8 super-eruption, that's just a completely different beast, something that dwarfs anything in human history. Okay, this chart right here says it all. Look way over on the left. You can see the famous eruptions, Pinatubo, Mount St. Helens, even Tambora, which caused the year without a summer. Now, look all the way to the right. That giant bar, that's the Toba super-eruption. The other ones are barely even visible next to it. That is the difference between a volcano and a supervolcano. The size of the explosion is one thing. It's hard to even wrap your head around. But the true global threat from a supereruption isn't the ash that falls down, but the gases that get shot way, way up. I mean, don't get me wrong. The pyroclastic flows would vaporize an area the size of a small country. But the long-term worldwide damage comes from something you can't even see, sulfur gases. So here's how that works. First, the eruption literally punches a hole in the atmosphere, shooting millions of tons of sulfur dioxide straight up into the stratosphere, high above any clouds or weather. Second, up there, the gas mixes with water and turns into this fine mist of sulfuric acid aerosols that spreads around the world. And third, that aerosol shield basically becomes a planetary mirror. It reflects sunlight back into space, causing global temperatures to plummet, and kicking off what's called a volcanic winter. This right here, this is Lake Toba in Indonesia. That entire lake is just filling the massive hole, the caldera, left behind by that super-eruption 74,000 years ago. An eruption this big doesn't just leave a scar on the land. It was powerful enough to trigger that exact kind of volcanic winter we were just talking about, changing the climate for the entire planet. All right, so now we get the stakes. A supervolcano isn't just a mountain, it's a planetary engine. And that brings us right back to Yellowstone and the mystery that had scientists completely stumped for years. The puzzle was this. The magma chamber we knew about under Yellowstone, while huge, just wasn't big enough to explain all the heat and carbon dioxide that was constantly leaking out at the surface. The math didn't add up. Something was missing. There had to be a deeper, bigger source of heat, but for the life of them, nobody could find it. So how did they finally find the missing piece? Well, they basically gave the planet a giant ultrasound. It's a technique called seismic tomography. They used the seismic waves from thousands of little earthquakes happening all over the globe. And by tracking how those waves traveled through the Earth, they could see where they slowed down. And where they slowed down, that signaled hot, partially molten rock. It allowed them to map what was hidden deep, deep down.
And this is what they found, the missing link. It wasn't one magma reservoir, but two. A whole connected system. You can see how the deep mantle plume acts like a blowtorch, feeding this newly discovered absolutely colossal lower reservoir, and that in turn feeds the shallower, stickier magma chamber we already knew about. They had finally found the complete plumbing system.
And let's just put these two in perspective. The upper chamber we've known about holds about 10,000 cubic kilometers of magma, but this new lower chamber, remember that number from the beginning? It's a staggering 46,000 cubic kilometers. It's 4.5 times bigger, sitting way deeper in the crust. This is the massive engine that finally explains all that heat and gas. It's the missing piece of the puzzle we started with.
So what does all this really mean for us? Now that we've found this monster, is Yellowstone suddenly more dangerous than we thought? Well, here's the crucial thing. Does this discovery mean the risk has gone up? No, not at all. The volcano is the same today as it was yesterday. The danger hasn't changed. What has changed is our knowledge. We've just pulled back the curtain a little further, and now we have a much more complete picture of one of the most powerful geological systems on Earth.
And it's just a good reminder that these systems are part of this vast, ancient process. As the researchers put it, Yellowstone only exists because the entire North American continent is slowly dragging itself across a permanent hotspot in the Earth's mantle, a process that's been going on for millions and millions of years.
You know, finding something this enormous, something we had absolutely no idea was even there, it really makes you wonder. It just goes to show you that even now, our planet is still full of these profound surprises, these huge secrets just waiting right under our feet to be discovered. What else is down there?